हेलो एवरीवन, दिस इज लेक्चर 281। इस लेक्चर में हम प्लास्टिक डिज़ाइन में शेप फैक्टर के बारे में डिस्कस करेंगे। तो सबसे पहले हम अब इस कंसेप्ट को क्लियर करना है कि प्लास्टिक एमपी दैट इज प्लास्टिक मोमेंट क्या होगा और इलास्टिक मोमेंट क्या होगा और इन दोनों में क्या रिलेशन है। तो सबसे पहले हम कोई एक रेक्टेंगल सेक्शन ले रहे हैं। सपोज करिए आपका एक रेक्टेंगल सेक्शन है और इसमें हम दर्शाना चाहते हैं कि आपका इलास्टिक जब डिफॉर्मेशन होगा, जब इलास्टिक होगा, दैट इज इलास्टिक है आपका, जब बॉडी इलास्टिक है और जब बॉडी आपकी प्लास्टिक डिफॉर्मेशन में जाएगी तो कैसे बिहेव करेगी। तो इफ़ यू सी, अगर आप देखें तो हमें इस तरह से प्लास्टिक में इस तरह का ग्राफ मिलेगा, इस तरह का एरिया मिलेगा। तो ये आपका दिस इज इलास्टिक न्यूट्रल एक्सिस, इलास्टिक NA, and this is your plastic neutral axis PNA. This is your plastic, this is your plastic, this is FY, this is again FY, this is your FY. तो now the elastic and plastic, इलास्टिक में हम लोग क्या समझते हैं, इलास्टिक में न्यूटन एक्सिस passes through centroid of section. सेक्शन के सेंट्रॉइड से पास करता है एंड मोमेंट एंड न्यूट्रल एक्सिस इज 0 एंड मोमेंट एट NA इज 0। ये इंपॉर्टेंट पॉइंट 1 है इलास्टिक के लिए। अब प्लास्टिक में क्या है, प्लास्टिक न्यूट्रल एक्सिस प्लास्टिक फॉर्म में क्या है कि द प्लास्टिक न्यूट्रल एक्सिस डिवाइड सेक्शन into two parts, into two equal parts और moment at PNA plastic neutral axis is total moment of tension and compression zone, which is your plastic moment। तो ये बेसिक हमारा इसमें दोनों में अंतर ये है कि इलास्टिक में न्यूट्रल एक्सिस पासेस थ्रू द सेंट्रॉइड। आप ध्यान रखिए इसके सेंट्रॉइड जो भी उस सेक्शन का या जो यूज करेंगे उसके सेंट्रॉइड से पास होगा, जबकि प्लास्टिक न्यूट्रल एक्सिस डिवाइड्स द सेक्शन इनटू टू इक्वल पार्ट्स, दोनों को हाफ करके एरिया में डिवाइड करेगा। और मोमेंट एट PNA इज अ टोटल मोमेंट ऑफ कंप्रेशन टेंशन एंड कंप्रेशन जोन which is called plastic moment। जबकि इसमें मोमेंट क्या है, दैट इज यहाँ पर अगर आपका P है और यहाँ पर आपका किसी पॉइंट पर अगर मान लीजिए C है, दिस इज योर यू कैन से C, अगर यहाँ पर मान लीजिए या किसी पॉइंट पर आपका C लग रहा है, तो P और C के बीच में आपका जो मोमेंट होगा उसके हिसाब से मान लीजिए आपका कहीं C अगर लग रहा है तो C ये हो गया और P हो गया, तो इन दोनों के बीच का जो लीवर आर्म है उनके हिसाब से ये मोमेंट हमारा कैरी करेगा। मोमेंट इज इक्वल टू TRC मल्टीप्लाई बाई द डिस्टेंस बिटवीन द सेंट्रॉइड ऑफ P एंड C के बीच में हमारा काम करेगा। इस तरह से यू कैन से दिस इज व्हाट वी ट्राई टू अंडरस्टैंड। तो यहाँ पर दो चीजें सामने हमारे निकल के आएंगी। तो ये हम कह सकते हैं कि अगर इलास्टिक के लिए हम लोग जेडी यूज करें और प्लास्टिक के लिए जेडपी यूज करें, तो दिस इज योर सेक्शन मॉडुलस, दिस इज योर सेक्शन मॉडुलस कहलाएगा, और इसको हम लोग प्लास्टिक मॉडुलस कह जाएंगे। दिस इज योर प्लास्टिक मॉडुलस, द सेक्शन मॉडुलस एंड प्लास्टिक मॉडुलस। अब सेक्शन मॉडुलस और प्लास्टिक मॉडुलस दो से जेडपी, तो जेडपी क्या है? जेडपी इज द सेक्शन प्लास्टिक मॉडुलस। प्लास्टिक मॉडुलस क्या होता है? प्लास्टिक मॉडुलस is summation of compression and tension areas about PNA. That is, plastic model is summation of compression and tension moment of you can say moment of compression and tension area about PNA. Let us first of all find out the shape factor for rectangle. Let us take this rectangle. This is your B and this is your D. This is your BD. So let us draw the elastic neutral axis ENA. This is your ENA is passing through the centroid. This is passing through the centroid. What is centroid of rectangle? The centroid of rectangle is the centroid of axis is dividing this d by 2, this also d by 2. Centroid of rectangle is at the half of the depth. So this your elastic zone passing through the centroid. And what is the maximum distance? This is your y max. This is y max. So y max both sides is same. Y max is same. And what is the, let us find out ZE for this thing. ZE equals to INA with respect to this the neutral axis. INA, this is your B d cube by 12. And what is Y max? Y max is equals to your from this neutral axis to top fiber, that is d by 2. So your ZD is question. ZD equals to, that is section modulus equals to I NA divided by Y max. So this is your BD cube by 12 divided by D by 2. So this is your BD cube into 2 divided by 12D. So this is your BD square by 6. This is BD square by 6. Now आप इसमें देखो कि मान लीजिए आपका ये B और D का सेक्शन है, तो इसके सेंट्रॉइड से पास करेगा। सेंट्रॉइड कहाँ होगा इसका सेंट्रॉइड इसके D के हाफ पे होगा, तो D by 2 पे ये पास कर रहा है। और इसका न्यूट्रल एक्सिस यहाँ का ना, दिस इज योर ENA इलास्टिक न्यूट्रल एक्सिस, दिस इज इलास्टिक न्यूट्रल एक्सिस। तो इसलिए ये इलास्टिक जोन में INA क्या होगा? BD cube by 12 होगा, और वाई मैक्स क्या होगा, डी बाई टू होगा। तो जेडी क्या होगा, आई एन ए बाई वाई मैक्स हमने किया है। तो बी डी क्यूब बाई 12 डिवाइडेड बाई टू बाई डी बाई टू, तो ये बी डी स्क्वायर बाई 6। तो जेडी इसका कितना निकल के आया, जेडी इक्वल्स टू योर बी डी स्क्वायर बाई 6। let us find out the ZP. Let us find out the ZP. तो ZP जब फाइंड आउट करना होगा तो क्या होगा, let us find out the ZP. तो this will be your BD is there, BD, and this divide half. So how can this half can be divided? This will be also at a distance of d by 2. This will be at a distance of d by 2. So the area A1, this area is your AC, and this area is your AT. AC equals to A by 2. A by 2 is equal to BD by 2, right? And AT equal to also A by 2 equals to your BD by 2, right? This is AC by 2. And what is distance of this is your plastic NA neutral axis. So your diagram of will be like this, in this way, in this way. This is your compression, and this is your tension. This is your compression. This is your compression. This is your inside compression, and this is your tension. This is your tension. This is compression, and this is a tension. So this is giving you moment like this, and this is giving moment like this. So those both are the same nature of moment. So see, and where this lies at a distance of, what is this distance? The half of this, this is d by 2 into 1 by 2. So this is at a distance of d by 4. And what is this distance? This is also 1 half in d by 2, 1 by half d by 2 equals to your d by 4. So the centroid, that is distance of C1 from this point is d by 4, and from this point is also d by 4. This is d by 4, this is also d by 4. So what is ZP? ZP is the AC into Y1 plus AT into Y2. What is AC? AC is your BD by 2. AC is BD by 2, and Y1 equals to your d by 4. And what is the AT? AT is also BD by 2. So this is plus BD by 2 into Y2 is equal to d by 4. So what will be this? This you can have BD by 2 common. We have d by 4 plus d by 4. So this will be your BD by 2 into BD by, d by 2. So this is your BD square by 4. BD square by 4. So ये आपको समझ में है. This is because the, अब यहाँ पर ये रिजल्ट निकलता है, the centroid axis and equal area axis coincides. Equal area coincides. So the elastic neutral axis and plastic neutral axis lies on the same line. रेक्टेंगल के केस में जो इसका इलास्टिक का न्यूट्रल एक्सिस होगा वही प्लास्टिक का भी न्यूट्रल एक्सिस होगा, और यहाँ पर m जो BD स्क्वायर ZP जो आएगा वो आपका BD स्क्वायर बाई 4 और जेडी जो आएगा बीडी स्क्वायर बाई 6 आएगा. सो योर एफ मीन्स सेफ फैक्टर इक्वल्स टू योर जेड पी अपॉन जेड ई. जेड पी इज हाउ मच? It is BD square by 6 and this is your BD square by 4. So this will be your BD square by 6 multiplied by 4 divided by BD square. Oh sorry. This is BD square by 4 divided by BD square by 6. So this will be your 6 by 4. So this will be 1.5. 1.5. So for rectangle, this will be 1.5. 1.5. If you take square, for the square, what will be for the square? For any size of rectangle, because rectangle, the shape factor equals to 1.5 because it does not depend on this VD square cancel out, so this is 6 by 4 always, so this is 1.5. So shape factor for any size of rectangle is 1.5. Let us see for the triangle, for the this thing square. What will be for the square? If you take square, this is your A, and this is also A. So this is your A by 2. This is A by 2. So for elastic neutral axis, this will be your A by 2 maximum, that is Y max, and ZE equals to INA divided by Y max. What is INA? INA equals to A, B, D means A cube by 12, right? And this NA equal to A by 2. So this will be A, BD cube. The A4 divided by 12 multiplied by 2 divided by A. This is your A cube by 6. This is A cube by 6. BA. Now ZD equals to A cube by 6. And what is ZP? ZP is your AC into Y1 plus AT into Y2. What is AC? AC is nothing, is this area, total area. Total area is A into A by 2. A by 2 into Y by 4, that is A by 4 plus A by 4. So this will be your A square by 2 into A by 2. So this will be A cube by 4. A cube by 4. So your shape factor equals to your A cube by 4 divided by A cube by 6. So this will be your 6 by 4. So this will be also 1.5. So this will be also 1.5. So the shape factor for rectangle and square is 1.5 if it is in this shape. This shape is something like this. This is square, this is rectangle, and this is your square. This is square and this is rectangle. So you can always find out the shape factor by the concept passing through the centroid for the elastic and passing, making half of the area, passing through the half of the area for the plastic neutral axis. So in this way you can have the shape vector. Let us try to understand some other shape of the section. So let us take a circular section. This is a rectangle and second is your circular section. Circular section. Let us say take a circle like this. This is circle. So neutral axis will pass through the centroid. This is your d by 2. This is your d by 2. And for this, what is ZE? ZE. This will be like this. The diagram will be something like this. So area. So this ZE equals to INA upon Y max. What is INA? INA equals to pi by 4 pi by 64 d to the power 4. Pi d4 by 64. INA for this neutral axis is pi d4 by 64. And what is the CG at this point? From this point. This point. We don't want CG, we want this distance, Y max. What is Y max? This is d by 2, d by 2 RR. So your ZE equals to your INA pi d 4 by 64 divided by d by 2. So this will be your pi d4 into 2 divided by 64 d. So this will be 32 and this pi d cube by 32. This is pi d cube by 32. So for the circular section, the section modulus is nothing pi d cube by 32. Simply we are taking the INA divided by this d by 2. And what will happen? That is ZE equals to section modulus for circular section equals to pi d cube by 32. Let us find out the ZP. What will be ZP? For ZP, the plastic neutral axis will pass through this, and the area will be something like this. This will be area something like this. This is your area. This is your AC and this is your AT. And what is the CG of this area from here? This is at a distance of 4r by 3 pi. 4r upon 3 pi. This also at a distance of 4r upon 3 pi. 4r upon 3 pi. So CG is at a distance of this is same at a distance of 4r upon 3 pi. So this lies at a distance of this compression lies C at a distance of 4r upon 3 pi, and this tension you can say this is compression, this is tension. Tension at a distance of 4r upon 3 pi. 4 upon r upon 3 pi. So what is the ZP? ZP is AC Y1 plus AT Y2. What is AC? AC is the half area. How much is the area? Area is pi b square by 4. Area is pi d square upon 4, half 1 by 2. And in bracket, what is Y1? is 4r upon 3 pi plus 4r upon 3 pi. So we can have pi d square upon 4 into 1 by 2 within bracket 2r means 2d. 2d upon 3 pi plus 2d upon 3 pi. This is your pi d square upon 8 multiply by 2 into 2d upon 3 pi. So what will be this? This is 2, 2, 4, 2 and this is pi cancel out. So this is your d cube upon 6. This is your d cube upon 6. So Zp for the circle, for the circular section is nothing d cube by 6. And what is the Zd? Is pi d cube by 32. So shape factor, what will be the shape factor? Shape factor is your Zp upon Zd. What is Zp? Zp is nothing d cube by 6. And what is your? This is pi d cube upon 32. 32. So this will be 32 upon 6 divided by pi. This will be 36 upon 6 pi. What is this value? Let us find out this value. This value is 32 divided by pi. Divided by 32 divided by 6, 5.33 upon pi equals to divided by pi 1.697. So this is 1.70. This is approximately 1.70. 1.6976. So this is 1.7. This is 1.7.